Section 11.7, factoring special cases. So for these, you're going to notice that the factoring with the boxes can still be the same, but throughout the day, throughout the lesson, you're going to notice something special that happens. So up on the top, we're still going to have 9 times 4 is 36, and on the bottom, we're going to have a negative 12. So to think of the two numbers that can do that, it's going to be negative 6 and negative 6. Negative 6 times negative 6 is 36. Negative 6 plus negative 6 is negative 12. So we split the middle up and we get negative 6p and negative 6p. We go with 9p squared minus 6p and negative 6p plus 4. When we do the boxes on that one, this column has a 3 and a p. This column has a 2, but it's negative. When you go with this row, they have a 3 and a p in common, but when you go this way, they have a 2, but it's negative. Notice how the top one and the side one are the same. It's going to be 3p minus 2 and 3p minus 2. Since they're identical, you can also write it as 3p minus 2 squared because it's just the same thing times itself. If you look at this one, though, there's something weird about it. There's only 2 terms. And what's happening is the middle term is really a 0. 0b, and then you have minus 4. So when you make your x's for this one, the first is 25, the last is negative 4, that makes negative 100, and then the middle term is really a 0. So the two numbers are 10 and negative 10. It doesn't matter which one you put first. Negative 10 times 10 is negative 100. Negative 10 plus 10 is 0. So when you do your boxes, this splits up this time into negative 10b and positive 10b. So we have 25b squared minus 10b, and then we make positive 10b, and then minus 4. When you look at these factors, it's going to be just slightly different. 5b, and then this one has a negative 2 in common. When you go this way, it's 5b, but it has a positive 2 in common. So it'd be 5b plus 2 and 5b minus 2. So notice the difference. This one had 3 terms. The first number was a perfect square. The second number was a perfect square. So we squared our answer. The middle number was negative, so our middle was negative. But this case, it had 2 terms because the middle term was gone. When that happens, that can only happen by 2 things that are exactly the same but opposites, one positive, one negative. So we have 5b plus 2 and 5b minus 2. Look for those clues when we do number 3 and 4. For number 3, when we make the box or make the x, it's 25 and 1. That's 25. And then for the bottom, it's 10. So you are looking for 2 numbers that make 25 when you when you multiply, and 10 when you add them. Those 2 numbers are 5 and 5. So when you do the boxes, it's 25b squared. The middle term got split up, 5b and 5b. So we have plus 5b, and then we have 5b, and then plus 1. So we have 5b in common, but this row only has a 1 in common. And then this one's 5b, but this one only has a 1 in common. So these are identical. When they're identical, you can just write 5b plus 1, and instead of rewriting it again, you can just say squared. Notice here, see that 25? If you take the square root of 25, you get 5 and 5. And then when you double 5 and 5, you get 10. So these are special cases. And this one, again, it's going to look more like x squared plus 0x and then minus 25. So that's going to be 1 times negative 25 is negative 25 and then 0 on the bottom. But those 2 numbers are going to be negative 5 and positive 5. So it's a special case where the numbers match. One sign is positive, one sign is negative. Since there's no number in front here besides a 1, I don't have to mess with the boxes. I can just simply say x minus 5 times x plus 5. So look for connections, look for patterns here. X squared, if you take the square root of that, you get x and x. Look at the 25. When you take the square root of 25, you get positive 5 and negative 5 because that's a minus sign right there. For this one, if you take the square root of 25b squared, you get 5b, which we had right here. If you take the square root of 1, you get 1, which we put right here. But since there was a middle term, you have to make it squared. You can't have one positive, one negative. So go down to the middle of the page. We'll do 5, 6, 7, and 8 another time. But here, there's special rules that happen for special cases. When you have a perfect square minus a perfect square, all you do is use the square root numbers, make one positive, and then make one negative. I'll show you with real numbers in a second. It'll make more sense, but just write this down. It's one of the rules that you need to know. And in this case, though, the middle term didn't cancel out. Here, the positive b and the negative b, it all canceled out. So the middle term was gone, but over here, the middle term is still there. So we're not going to have opposite signs. We're going to have the same sign, a plus b, and then you square it. And then we're going to have a minus b for this one, and then you square it because the middle term didn't go away. So let me show you with numbers really fast. Number 9. This one you don't even have to make an x. You just look. This is a 16n squared. You take the square root, you get 4n. This is 1. You take the square root, you get 1. All you have to decide is if it's positive or negative. Since the middle number is negative, you make it negative. And then decide if you need to square it or if you need to make the middle term cancel out by making one positive and one negative. Well, since there's 3 terms here, it's going to fit this rule right here. So we're going to make it squared. This one, though, it doesn't have a middle term. The middle term got canceled, and that only happened by having one positive and one negative of the same thing. So the square root of b squared is b, the square root of 1 is 1, and it's minus. But in order to make that middle term cancel like it did, we have to have it times something that's identical but with a different sign. So anytime there's only 2 terms where the middle term canceled out like that, you make b minus 1 and b plus 1. The next one, square root of 9r squared is 3r. Square root of 16 is 4. Decide if it's positive or negative by looking right here. That one's a negative. And since there was a middle term, we square it. For this one, you take the square root of x squared, you get x. You've got a 2. For the square root of 4, it's minus. But there's no middle term in there, in between them. So that's when I have to multiply it by x plus 2, knowing that the positive and the negative will eventually cancel each other out. Number 13, take the square root here, you get 5n. Take the square root here, you get 4. The middle number makes it negative. Since there is a middle number, I square it. For this one, take the square root, you get m. Take the square root of 16, you get 4. It is minus, but since the middle term is gone, that means one was positive and one was negative so that they could cancel out. And the last two, the square root here is square root of 25x squared is 5x. Square root here is 2. The middle term is minus, so you make it minus and you square it because there was a middle term. Here we go with 5k, and here we go with 3. It's negative, but since there's no middle term there, I can't square it. I have to multiply it by the same thing with the opposite sign.